All right, algebra 2. We're going to go ahead and start the graphing. I'm going to break this up into two parts. We'll do part 1, which is pretty much the setup for exponential graphing, and then we'll do part 2 in the next lesson. So we're going to go ahead and graph y equals 5 to the x. So we can make an x-y table, and so we can use like from -2 to +2, so 5 values. To find the y coordinates, and then we can go ahead and plot these ordered pairs so we can see the shape. All right, so if we put -2 in for x, you can use calculator on this also, but 5 to the -2 is going to be the same as 1 over 5 to the +2, which would be 1 over 25, right? So again, you're just putting -2 in for x. And then putting -1 in, that's going to be 1 over 5. And 0 in, that's 1. 5 to the first is 5. And then 5 to the second is 25. And we can go ahead and plot these points. So -2 and then up 1/25. So it's a really small number, but it's positive. And then -1 1/5. So it's just a little bit higher. 0 1 1 5. And then 2 positive 25. That's going to be up here, past the 20. All right, and so this is the shape of this graph. We connect them. All right, so an exponential graph has the parent function as y equals b to the x power. And if b is greater than 1, then the shape of the graph will look like this. Now, there's a horizontal asymptote that's going to occur, and that's going to occur on the x-axis. So it's like a boundary line that the graph gets close to. Here, that's the x-axis. And it's not going to touch it, it's not going to cross it. And so in this case, if we're writing the equation of the x-axis, this asymptote, it's going to be y equals 0. The domain, if we look at what vertical lines intersect this graph as we move left to right, it's going to be -infinity to +infinity. And then the range, if we look at what horizontal lines intersect this graph as we move bottom to top, it's going to be, as soon as we pass 0, and then go all the way up to +infinity. Now 0 is going to have a parentheses, and that's because the graph will never actually hit the x-axis at 0, so it will hit just above it. All right, so let's do y equals 1/4 to the x. So again, using -2 to +2. So this would be 1/4 to the -2. Now, if you flip this, 1 over 4 becomes 4. So if you flip 1 over 4 and do the reciprocal, then you have to change the sign of the -2. So then it becomes +2. And that's the same as 16. And you can check it on your calculator. 1/4 to the -2 does equal 16. And then putting -1 in. Okay, again, you could flip the fraction and then change the sign to a positive. So that would be 4 to the +1, which would be 4. And then 1/4 to the 0, that's just 1. 1/4 to the first is 1/4, or 0.25. And then 1/4 to the second is going to be 1 over 16. All right, and then let's go ahead and plot these points. So -2, +16, -1, +4, 0 1, 1 1/4, and then 2, 1, 6, 2. Right, so here's the shape of this graph. Connect them. All right, so on this parent function equation, again, it's in the form of y equals b to the x. But if b is a fraction, so it's between 0 and 1, so bigger than 0 but less than 1, then the shape of the graph is going to look like this. All right, so it has, again, a horizontal asymptote, and that's going to occur again on the x-axis here. It's our boundary line. So the equation would be y equals 0. The domain, again, if you look at what vertical lines intersect this graph, moving left to right, everything would hit, so negative infinity to positive infinity. And then the range, if you go bottom to top, the horizontal lines would intersect this graph as soon as you pass 0 and then hit at positive infinity. So again, it'll be 0 to positive infinity. All right, so number 3, y equals negative 2 times 3 to the x power. So the parent function, again, is y equals b to the x. So in this case, it would be y equals 3 to the x power. Now, there is some transformations that are occurring now. And so the negative, again, we'll do an x-axis reflection. X-axis reflection. And then the 2, since it's bigger than 1, it's going to do a vertical stretch by 2. All right, so when we do our xy table, it's based off the parent function y equals 3 to the x, and then we can apply the transformations. You can do, really as many points as you want, but do at least 3. And so we always want to at least use negative 1, 0, 1 for x. Right? So plugging negative 1 in to y equals 3 to the x, that's going to be 1/3. 3 to the 0 is 1, and 3 to the first is 3. Okay, now we can apply the transformations. Since the negative and the 2 are on the outside of the parentheses, that's going to affect y, right? And so we'll make a new column for y. And we're going to multiply all the y's by negative 2. So negative 2 times 1/3 would be negative 2/3. Negative 2 times 1 is negative 2. And 3 times negative 2 is negative 6. All right, so we're going to use the negative 2, and negative 6 as our new y values. So let's go ahead and plot these points. So negative 1, and then negative 2/3. 0, negative 2. And then 1, negative 6. Right, again, we have this horizontal asymptote. It's our boundary line. It's going to occur on the x-axis for now. And so we can see with these 3 points, again, you can do more points. You could put in negative 2, positive 2, but this is the shape of this graph. All right, so remember it got flipped over the x-axis, so that's why it's pointing down instead of pointing up. All right, so again, our horizontal asymptote is y equals 0. Domain is negative infinity to positive infinity. The range, as we move bottom to top, it's going to first hit at negative infinity and then go to 0. All right, and then let's go ahead and do this last one. Y equals 1/4 times 1/2 to the x power. Okay, so our parent function will be y equals 1/2 to the x. This has a transformation that's being multiplied by 1/4, so that means it's a vertical shrink by 1/4. And shrinking because 1/4 is less than 1. All right, so putting negative 1 into 1/2 to the x power. Okay, so 1/2 to the negative 1 is going to actually be 2. 1/2 to the 0 power is 1. And 1/2 to the first power is 1/2. All right, now we can apply the transformation. So 1/4, since it's on the outside, it's going to affect the y values again. So make a new column here. And we're going to multiply each y value by 1/4. So 2 times 1/4 is 2/4, which is a half, or 0.5. 1/4 times 1 is 1/4. And 1/4 times 1/2 is 1/8. All right, so those are our new y values. All right, so plotting these points, negative 1, and then up a half. 0, 1/4, too small here. And then 1, 1/8, that's even smaller. So now connecting these, this is what it's going to look like. Okay, again, we can put in that boundary line, the asymptote is right here again on the x-axis. So the horizontal asymptote, again, is y equals 0. Our domain, negative infinity to positive infinity. And the range is going to be 0 to positive infinity. All right, and that's it.